Like your
Sounds great,
background,
man.
by the way. Like your
Oh, thank
background,
you.
by the way.
Thank you. I try to keep it fresh.
Very good. Very good.
Yeah, no, and you know, I think most folks that know me know that I have no problem when we have something bad to say about our company, that I'm not too shy about saying it. So,
Right.
you know, I'm a lover, but I'm not a dreamer. How's that?
That's right. There you go. Very good. Very good.
Yeah, and thank you for the warm introduction and you know, all that stuff. There's you know, a lot of the good stuff's coming back. I will say I was able to do this session in person in the Burlington office and up here in Mass a couple months ago, and you know, we only had a handful of people there, but it feels so good to be back in person. You know, in these situations with customers and everything else. So you know, it's certainly it's nice to be able to have that capability to be able to, you know, remotely present to a user group and stuff like that. But at the same time, just being in person for me is just never the same. We ran it hybrid and it seemed to work out pretty well. People were able to ask questions and all that stuff. So, you know, hopefully going forward, we can do this for everybody, right? Just even more accessible for folks having trouble getting out of their house and stuff. So, um, it's great to be back. So today we're going to go a little off topic from the traditional NovaSQL group, right? And so, great idea bringing in the AI group with Prashant and stuff. You know,
Absolutely.
because some of this I think you know will maybe loosely ring home, right? The purpose of this is to kind of just give everybody an overview of the computer vision service that Microsoft provides. You know, and there's a whole bunch of stuff that happens in the background that we don't always see. You know, or you know, we could, right? And we should if we're putting this stuff into production. But you know, from a pure, you know, presentation standpoint, you know, there's a lot you can do right through the GUI. So we'll get through that after we kind of talk about a little bit of the history here and go from there. So yeah, as Tim mentioned, I'm Chris Seferlis. So I'm an account technology strategist at Microsoft. So this title just changed as well at our fiscal year. I was a client technology lead until July, and now I'm again an account technology strategist. Uh, Army veteran, as Tim mentioned, YouTube channel, which is severely lacking. But on my next slide, you'll see why. And so I'll get caught up, and by the end of the year, I'm hoping to push out some more Synapse content. You know, some comparison content between data mesh and data warehouse and data lake and, you know, Delta Lake and all that good stuff. So I've got a bunch of stuff queued up. It's just, you know, time is a little bit tough right now. So you know, LinkedIn, Twitter, you guys got questions, always happy to help out. Do a lot of mentoring with folks. You know, they'll reach out to me, you know, just to kind of ask about, you know, it could be career related, it could be resume related, it could be, you know, path related, if you will, and it could be, you know, very much tech related too, right? You know, I do a lot in data architectures and stuff like that, and so. Feel free to reach out. Happy to help out. If I can't find you an answer, I'll do my best to find you an answer, but I can't make any promises. So, um, so the only plug I'm going to make is my book. This is one of the reasons why it's been really tough to make videos, because any of my free time I've tried to push hard to get this book written. So right now we're aiming for a November December release. You know, that assumes that myself and my co-authors can you know, get things deployed. We're about 2/3 of the way through, coming up on 3/4 after I finish this chapter. And you know, so basically what I did was I was approached by Pact about a year ago to um, you know, develop a book based on cognitive services. And so it looks at all the cognitive services, and it's meant to be intermediate, right? So we have some code snippets in there, you know, we've got some examples, but then it also relates back to a lot of my experience as a CIO, and a lot of the areas within the seafood manufacturing company I worked for, the two of them actually, where you know, I was able to identify areas where the company could, you know, whether it be improve customer service, whether it be enhance operations, you know, increase productivity, those types of things, and basically take that and kind of be able to apply what the cognitive services are that you could use, right? And so Essentially taking all of that experience, almost 10 years at the two companies, and being on the manufacturing floor regularly, and then saying, okay, how would we apply AI to these solutions? And so it's based on a fictitious seafood company. Seafood manufacturing is a very complex process. And so, like I said, we're quite a ways through it now. And I've got another partner here from Microsoft that's helping to write the book, and another developer as well. So we'll have code samples, we'll have all the templates available for download. We'll actually have a working demo site, as long as it's as long as we don't run out of Azure credits to be able to run it. And so just follow me on social, and I can guarantee you'll see when it gets released. So if anybody's interested in reviewing it, right, reviewing a chapter, reviewing the whole book, leave a full review on Amazon. Pact is offering a free subscription to their yearly service where all of the Pact books are available. Again, reach out to me if you have any questions about that, or if you're interested in being a reviewer of either a chapter or the whole book. The whole book is not as deep technically, if you will. So if you just want to read the book to get some get an overview of it and stuff, and then write a review about it, that's one track, and they'll give you the subscription. The other track is go through and do a deep dive on a single chapter where you actually build the example. You follow the chapter, and basically tell me where I was wrong on certain areas. So, if anybody's interested in that, please feel free to reach out and let me know. That's the end of the plug. Okay. So what is computer vision, right? That's what we're here to answer today. And when we talk about it, right, from a pure definition standpoint, it's really the study of building artificial systems that process, perceive, and reason about visual data. So what does that mean, right? Essentially, when we're identifying what's happening in an image, right, and we're doing that processing, perceiving, and reasoning about that data, we're going through and we're analyzing what's in our vision, right? And so this one pokes fun a little bit at CAPTCHAs, right? And so anybody who's not aware, CAPTCHA and reCAPTCHA, was developed by Google. It was open sourced, and the whole gist of that is you're actually helping to refine AI models for text and language and pictures, right? And so pick out the pictures that have a stop sign, that kind of thing, right? And so basically, when we work with a reCAPTCHA, because CAPTCHAs are pretty much dead, I think, at this point. But when we're working with a reCAPTCHA, we're just helping to reinforce that model and improve it. And so that's why you kind of get like some of those really, really squirrely text reCAPTCHAs. If anybody watches America's Got Talent, they just poked fun at that a couple of weeks ago. There's an engineer who's a comedian, and he had a bunch of examples up on stage, and he's like, how the hell am I supposed to read this, right? So it was pretty funny, but it's about how tightly distinct can we get with our recognition of characters when they have strike throughs, when they're all squiggly and stuff like that, and then of course images. And so when we talk about computer vision, we really want to take the opportunity to kind of look at how we are going through the process of analyzing these images and talking about what they're all about, right? So a few examples, right? What is this image? Real quick and dirty, it's an airplane, right? I see an airplane in the background too. But that seems to be the focal point of the image, right? Anybody who's ever taken any kind of photography class, you want to focus on the center of the image. Whatever your focus point is in the center of the image. So if you're, capturing a picture of a mountain or people or whatever, you want it to be in the middle because that's where people are going to look naturally, right? And so, out of the gate, this is an airplane, right? But when we start looking at computer vision, right, we start to look at other objects, right? And so we're doing object detection. We're seeing people, and we're seeing a couple of airplanes, right? And so essentially we're identifying these, and in this case, you can see we're highlighting around the particular objects with some kind of highlighted box, and we're essentially saying, okay, now we see two airplanes and two people, right? And then finally, we want to look at the segmentation, right? we want to be able to identify where exactly these objects are that we identified in the image, so that if we need to um, uh, hone in on that image, right? So if we're gonna if we use the person in the bottom left, for example, right, and we want to hone in on that person, we want to have that capability of knowing where it is within the image, so that if we're doing some kind of object recognition, or we're doing even facial recognition or something like that, assuming the image quality is good enough, we can use that type of location finder, if you will, as we segment out the image. Oh, by the way, guys, if anybody has any questions, just feel free to shout them out. I don't see the chat while I'm presenting, so definitely feel free to ask any questions out loud or throw them in the chat. And Tim,
Right.
Prashant, you guys can let me know.
No questions so far.
Got it. Cool. Okay, so what's the evolution, right? Everybody should be able to recognize this, I hope. If anybody wants to come off mute and shout it out, but it's the cockpit, if you will, of a Tesla, right? And so we're looking out the front windshield. We've got a person driving the car, and we all know the great capability that Tesla has brought to the world in the way of self-driving automobiles, right? All the I guess independent individual instances where there's been challenges, around safety and stuff like that, are all fairly questionable as to whether it was the car's fault, right? I remember the first person who passed away while driving a Tesla. He was, I believe, either asleep or watching a movie, and he crashed into the back of a trailer truck because it was so high up off the ground, the car couldn't see it. It didn't know there was a bumper there, right? But regardless, he wasn't paying attention. So if he were driving, it would have had the similar result, most likely, right? And so the question becomes, like, are we safer with autonomous vehicles? And I would personally say yes. People have different feelings about it. We're not gonna argue the merits of that either way. But this is where we are today. But I want to look at where we came from, right? Because right now we're able to identify all of these objects within the image. We've got traffic lights, we've got the crosswalk, we've got the people, we've got other cars, we've got all of these hazards that we're concerned about, and we want to make sure we're aware of, right? And at the same time, the massive amounts of data that are being pushed up into Tesla's cloud to be able to capture all of what's happening in real time with these vehicles, whether it be the vehicle itself or what's happening around the vehicle, all gets reported back. And so, when you think of the integrated navigation, the traffic, those types of things, now we can see that we've got a lane closed, right, on this particular road. That all gets reported up. So the next guy behind us in a Tesla is being notified that there's a lane closure coming up ahead of time, right? So a lot of this stuff's been around for a while now. So I think we've had the autonomous mode for probably 5-6 years at this point with the Teslas alone. And so, it's kind of nothing new to people, right? But awesome technology regardless. Now, where does this come from? The idea was actually started back in the late 50s, believe it or not. And what we know of as, compute and computers and a lot of that technology is just, completely out the window from back then. But the original intent was to determine whether or not we could mimic mammalic vision, right? So can we see as a mammal sees? And the way they did it, believe it or not, was they actually took an electrode and probed it in the back of a cat's head. A live cat, and again, we don't want to talk about ethical treatment of animals or any of that stuff, right? That's not what we're here for. But this was an experiment that they did back in the late 50s, where because the way a cat sees is so similar to the way a human sees, they wanted to be able to see how the brain reacted while they were actually looking at an image. And so what they did was they put them in front of a screen, and then they hooked up this electrode to a nerve, and they basically said, okay, we're going to flash a bunch of different things. And so they basically traced how the brain recognized the various shapes, the blurred edges, the sharp edges, and all of sort of the different areas. And we'll kind of boil that down here a little bit more. But they wanted to see how this all got all get built as to how to recognize what an actual image was. And when we look at the pre-processing aspects of this, right? It's essentially what we want to do is we want to improve that quality so that we can help to recognize images better, right? And at the long and short of it, when we think about how an image is built, it's a grid, right? I mean, it's an XY axis. It's got a number of pixels, depending on how pixelated the image is. You look at your computer screen, and all that stuff. That's all it is, right? It's a 1024 by 768 image, right? Or whatever the resolution happens to be. And so by taking that, you look at it on a pixel by pixel basis, and you simplify what's happening in that image. And so the way we process those images, right, is we will convert it to grayscale. So we take an image, right, and then we convert it to grayscale. And so, essentially, we've stripped all the color out to reduce the complexity, okay? And then we do some equalization. We increase the contrast so that we can more definitively pull out what's happening in the image, right? And find out where we have sort of that parity between the negatives and positives, or the blacks and whites, if you will, right? And then we apply filters to it, right? And so what the filters do is they remove the noise, and there are a bunch of different filters. There's edges, there's blurs, there's a whole bunch of different ones, radiance and all kinds of stuff, right? And so basically what we do is we remove all of that extra stuff in the image, because believe it or not, when we actually break these down and simplify what's happening in the image, when we do recognition, we don't really care about what's happening outside of our target recognition component. And so I work with a customer up here in the Northeast, and they're considered to be a leader in computer vision. They've got a bunch of PhDs running around and stuff like that. And they've got these really, really fancy high-tech AI-based cameras that can do computer vision. And they're only 3 megapixel, right? So when you look at like what the megapixel is of your cell phone, say, 12, 15, 20 megabytes, right? Or you all know what I'm talking about, megapixels. Essentially, we're actually diluting that image quality when we do recognition. Okay. And so basically what that allows us to do is to kind of get a more focused area on specifically what we want to do recognition on. So then we detect our edges, right? And that's one of those filters. Essentially from there, we go through and we run all of our different our different filters. We've got, as you can see, right? You start with your image here on the left. You work with your low-level filters, your lines, your edges, your colors, all that stuff, right? And then you take your high-level features, which are the corners, the contours, the shapes, all those. And then you look at what's happening in the image, right? You start to break down those objects, and then finally you can classify that image, right? And so this is a deep neural network. Convolutional neural networks are the algorithms that are happening behind the scenes that are helping us to identify what's happening. And if you look at the sort of stream here at the bottom, essentially what we do is we've got an image of a cat, and then we take a grid of the image. Right. And so again, we talked about the 1024 by 768 image. And then from there, we take a small swath within that overall image. It could be 3 by 3, it could be 4 by 4 pixels. And then we essentially scan the image all the way across from top to bottom. And essentially that's how we apply these filters as we are, identifying the various areas of the image that we want to take interest in, right? So after we apply those filters, and now we've identified an object, we can basically say, okay, compared to the existing objects within my model, I can say, yes, this looks mostly like a cat. And in this particular image here, you can see is a little bit distorted. And that's something that we have to take into account, right? Because as humans, we can clearly see that that's a cat, right? But if we couldn't see, right, which is obviously a use case for something like this, or say, we were a computer, right, and it was skewed so that you couldn't quite tell it was a cat, we need to make certain adjustments for that type of thing, right? Or let's just say the cat turns around and is upside down, right? You can't see its more distinctive features. You're looking at the derriere of the cat, if you will, and essentially you don't know what that could be, right? It could be any kind of butt, right? So, essentially when we do that, right? Yes, sir.
I have a question about convolutional layers, if
Yeah.
I might. So I know how convolution works, but I'm not sure what happens in case of colorful picture. If we have three layers, red, blue, and green,
Mhm.
and we apply convolution, is each of three images convoluted separately, or is
Yep.
it somehow joined?
It does. So it takes it as three separate filters. It breaks it down by color and takes them as three separate filters. And then that, so when we look at within this particular component, right, the low level feature filters, that's when you start to break it down. And I'll actually, I don't have the slide handy. I've got a reference I can send you if you just shoot me a quick note or put your email in the chat. I'll send it to you. It actually shows how it breaks down all of the colors into RGB.
Okay, so completely different convolution can be learned by a network for red and for blue color, right?
Correct. Yep.
Okay, thank you.
Yep. Sure. And so, basically we've got our base image data set with all the labels, as they've been built over time, right? So, we essentially are retraining our models constantly and improving them, adding new pictures of cats. And hey, maybe we've got the butt of a cat in our model, right? To identify that this is a cat from behind. And then we do our image processing, we do our classification based on the results, and then we say, okay, what does this most resemble? And then we get a sort of a percentage of likelihood that it's a cat, right? So traditional sort of prediction elements when it comes to machine learning and AI. So when we look at why this has become so important, is, as with a lot of things, it's become important in industry, right? A lot of companies are taking advantage of this technology to enhance or optimize what they're doing, right? So we can see over the last 5-6 years, we've got massive growth in the automotive industry, we've got massive growth in the consumer industries, right? Obviously, our phones, the smartphone market, some of the leading ones have more computational power from an AI perspective to be able to use our phones for some of these capabilities. At the end of the day, it's a computer in your pocket, but now they're, putting in some of these more advanced chips to be able to hasten the process of, being able to make these identifications and things like that. Microsoft makes the Seeing AI app. And basically it's a free app on iOS. I still don't think they have one for Android yet. But it's got object recognition, it's got facial recognition, it's got currency recognition, text, all that kind of stuff. And it's meant to be for accessibility purposes where, you can hold it up to somebody's face, it's going to do a prediction. And they might have pulled this feature out because of some concerns around diversity and things like that. So I'm not sure. I haven't seen the latest version, but essentially you could hold it up to a person's face and it would say, 42-year-old man smiling or frowning or angry or whatever. My kids get a kick out of it because it'll say that I'm anywhere from 30 to 70, depending on, where my facial hair is at, what I'm wearing, is my face somewhat obscured by a hat and things like that. So they get a kick out of it. But the idea there is really about accessibility and helping people who have disabilities that, whether it be, seeing and reading text and things like that, it can really help out. But as with a lot of things that help us out, it's born out of some kind of commercial need a lot of times, because that's the only way to get funding behind it, right? And so we rely on the Microsofts, the Googles, the Amazons of the world to build these next generation systems that can support this. And then we've got some of the smaller companies who can come in and build applications around it and devices around it and stuff like that. I'm running long on time, so I don't need to get into this, but it actually talks about some of the built models over time, AlexNet, ResNet. So these are some that were literally started in the 60s about how to train these neural networks and stuff like that. All the math is in there and everything else too. And now we look at what, a traditional pipeline, right? So, obviously we've got ML ops where we're, constantly making sure that our models are being updated, right? So we're capturing the image, we're doing any of the transformation stuff, adding those filters on, we're analyzing it, and then we're saying, okay, this is what we think is happening. And then we kind of go through that whole process, after we retrain our model and add some kind of a feedback mechanism, right? So we say, yes, this is a cat, which gives us, more strength, if you will, of that model, because we've got, more confirmation that it is in fact a cat. Now, one of the problems with that is if it's an open system, and this is something that we do touch on briefly in the book, but if it's an open system where instead you're you've got somebody who's in there malicious and stuffing that model with untrue results, or saying that it's not a cat, if you will, we run into problems with that. And so how do you legislate that? How do you regulate that? How do you delegate that and stuff like that? So these are some of the more societal problems that we run into as a result. Just a few practical use cases that we're seeing out there, right? Defects from a quality perspective, medical analysis, if you will, right? So, things that are happening within our bodies and stuff like that. It speaks largely to the state of our healthcare systems, where we've got the technology to much more accurately determine whether or not somebody has cancer from a mammogram or an x-ray or an MRI or whatever. And but doctors are very hesitant about it, because they're used to the way they do things, right? And so they're a little nervous about what the technology is going to do. So it just hasn't been adopted as quickly as possible. And I'm up here in the Boston area, and it's leading edge up here, but the technology is there, so it'll be interesting to see what happens. We've got some great use cases on our public sites around workplace safety, right? So is the person wearing a hard hat, right? Using computer vision to make sure that's happening. Did somebody step on an assembly line, or is something potentially dangerous happening in one of our plants, where we can literally shut down production using an IoT device because there's a safety incident. A company like Shell, there's a public use case where they are using AI cameras at some of their gas stations in a beta way to determine if something is going to happen with a gas pump handle, right? Is somebody using a gas pump maliciously, right? So they can shut the pump off using AI and IoT, right? So there's a lot of really cool examples happening out there, and definitely worth checking out. But it's all using this basis, again, that was started back in the late 50s. So when we look at the intent of computer vision, right, it's really to be able to do the image classification stuff, but then there's also other components here, right? So in certain images, you want to be able to say what's happening within the image, right? So you think of a barn that's sitting in a field, at a sunrise, with a cow in the field. You want to be able to describe that, and so the software can describe the elements that are within the image itself. And the Seeing AI app actually has something like that, right, where you can point your phone at a park and two children playing ball in a park, whatever. celebrity and landmarks, OCR, right? Just perfecting OCR, if you will, handwriting recognition. OCR has been around forever, as everybody knows, but having that ability to really hone in on OCR, going back to my reCAPTCHA example. The video indexer, right? So face detection. This is a sensitive subject in a lot of ways for both good and bad things, right? Microsoft has come right out and said, look, we are not going to sell our facial detection software to law enforcement. And as Microsoft employees, Tim and I are, we sign basically a contract, if you will. It's not really a contract in the old school, but we're basically guaranteeing and we're acknowledging the fact that we are responsible to report if we see a customer or a partner or somebody using our technology to be able to sell it to law enforcement, for that purpose, for facial recognition, right? So it's something that Microsoft takes very, very seriously, and it's a stance that they've taken and said, we're not going to do this. We talked about the scene detection, recognizing speakers, and this is really important. When you're at a conference and we're talking back and forth, and you want to be able to note when Mark Rusinovich pops in here and starts telling us about the latest Azure data center awesomeness, right? That's probably not going to happen, but you never know, right? So basically, it gives us that opportunity to kind of see, like, okay, who's speaking on the video, when does the camera shift from one person to another, if you want to pick it up specifically in an area or identify who the people are. They actually get a thumbprint of their face, if you will, that gets generated. And obviously you go way down the line of like deep fakes and all that kind of stuff that a lot of this technology is being used for. But again, it's stuff that we need to be very, very aware of, because it can be very dangerous in the world. When we look at an architecture, just real quick, this is just a sample full deployment of an architecture, right? So we have our images, we load them into storage, right? We multiple ways you can do that. There's multiple tools you can do it with. In this case, we're using an Azure function, sorry, and loading it into storage. And then we're using Event Grid to send some notifications, and we're telling another Azure function to do something else, right? We're going to pass it through our computer vision API. We're going to look at our vision model. We can play around with that model within a data science VM, if you will. We have the ability to build our own custom models, and also use the existing models and enhance them for our own purposes. Like, so think of business domain needs, right? If the model isn't generated with the widget that you're producing, we're going to feed that information into the model to say, yep, this is a widget, and this is a widget, and this is a widget, so that when we're doing any kind of detection on, say, quality, we want to be able to make sure that we're identifying that as a widget and it is built correctly. Where a canned model that Microsoft built wouldn't contain that information. From there, we can output the data to a database, Cosmos, SQL. We use those as examples, but the sky's the limit there. And then from there, we've got all these sort of related things, right? We've got an application that's consuming, we've got Power BI dashboards, we've got a logic app that's sending an email based on some activity, right? We've got log analytics, we've got app insights, and these are all sort of the peripheral things that we would use to build sort of a full production deployment using computer vision. All right, so now when we jump into our custom vision website, it requires an Azure logon, right? So just bear that in mind. It's not a separate logon. You'd use your Azure account, and basically you've got the ability to create a new project. I've got one that we'll reference back here in just a minute. But when we go and create a new project, there are a few things to note, right? How are you going to use the service, right? You've got the ability to use a couple different tiers. In this case, I'm using the standard tier. We've got a free tier for X number of images and X amount of processing and stuff like that. Really just to kind of play around with it, build a small POC or something like that. We make the determination, are we doing classification or object detection, right? So are we classifying the whole image, or are we looking for objects within that image? The next thing is, what classification types are we doing? Are we going to label multiple images, multiple objects within that image, or are we only using a single tag to be able to say, this is a cat, right? And then we look at the domains, and without going into great detail about the domains, you can see, some of them are named for specifically what they are, right? Food, landmarks, retail. But then you've got the general domains for your classifications. And basically, these are helping to, maybe, like I said, use one of those base models, or just sort of a general model that has a lot of the capabilities. Now, these are specific. If you go in and you look at where the different descriptions, they'll tell you what they're good for. General A1 is better for a situation where you have larger images, right? And they take longer to process. General A2 might be smaller images, but more of them, or something like that. I don't remember the exact specifics, but all the documentation lists it pretty well, and it gives you a good idea of what you should start with. And then, of course, down the bottom here, we've got that compact capability. And that allows us to deploy these models directly to our AI smartphones, AI-enabled smartphones, and allows you to take advantage of that like seeing AI application that I mentioned earlier. And so these are sort of, they call them compact because they're running much more compact, and they are allowing you to build these models that can be deployed out to those phones. And then when we look at an existing project here, and this, you guys can build this yourself. It's right there on the Microsoft Learning website. For example purposes, I created my own label. It's clearly not an artwork; it's a cat, right? But I added my own image in there. But a great example of this is that in the last talk I gave on this, one of the guys in the audience was an art lover, and he said, did you know, or I'm surprised that there's no pictures of Jokers here. And I was unaware, but apparently Picasso started his paintings by painting Jokers. And so when we look at, if we just do a quick search here, right, and we just look for, right, so if we look at our images and we show this real quick, right, so you've got a whole bunch of different images, right, and just look for a Picasso Joker. And so I've got some options about how I do this. Now I can load my files directly into my storage account and then do any of the tagging or anything like that I want, or I can use an API, right? So if I want to add an image, I can basically go in and add, bear with me a second, I'm looking for my, uh-oh, did they change it on me? No, I test it. That's what I was looking for. So I've got the ability, I've got my model built already, right? And I can go in here and I can test an image by grabbing a file that I have locally or pointing it to a URL. So if I grab one of my Joker images here and I want to copy the image link, and I can put it in to here, go back, and I can say, okay, test that. Is it a Picasso? And in this case, 99.9% probability that it was a Picasso. Okay. And so, as I mentioned sort of off the top, these GUI tools give you the ability to build your models as you need them, right? So you can do all of your model development in here, where you can label your images and you can go through. It has the ability to go in and automatically label an image. So if I just pull in, see what I can find here for a random image. Yeah, okay. So if I want to add an image, and we're going to bring our little friend the Twitter logo just for fun of it. So I can add a tag, an existing tag if I want, or I can just leave it untagged if I want, right? And then I upload the file. It goes pretty quick, right? And then it shows that it's an untagged image, right? So based on the tags that I've already created, or labels as they're commonly referred to, I can get a suggested tag. And this is a smart labeler, if you will, right? And so basically it says, I want to go through and detect any of the images that don't have a tag applied to them to be able to go through and say, okay, what kind of image is this? Now let's see what it comes back with, because I'll be curious if it comes back with anything good. Nope, nothing good. But if I take copy of this, and I add in another Picasso that's not here, right? I want to get my suggested tags again. It's going to go through, it's going to analyze them again. Why it wasn't popping up with my suggestions. Usually not this slow. Well, but anyway, what it's doing in the background here is it's actually going through and it's saying, okay, I've got a model that is based on all of the images that I've loaded in there, right? So going back to our rudimentary example of putting out a 1024 by 768 image, I've gone through and I've applied all the filters to that image, and I've pulled out the sort of important components of that image, right? And so in the case of, say, a painting, you would think of the way that the brush strokes go, or the color schemes, or other discernible, distinguishable aspects of how a painter paints. And so there's commonality in that, and even more so when you can see it in person, when you kind of read about what art historians do and how they determine whether something is a fake or not. A lot of times it can come down to literally the thickness of the brush strokes and how much paint is being left on the paper, or canvas, if you will, from all of those, other paintings that they used and compared them side by side. And so they go through a very meticulous process to say, this is a fake or it's not, and that kind of thing. I don't know why this is taking so long. So the demo gods are not smiling on me today. Usually it's much, much quicker than this. But if we go back, right, so you've got a threshold that you can set based on, where you want the confidence to be that it is, in fact, what you're asking it. And then we can kind of go through and we can look at the performance of our model as it was deployed. So you've got the precision, and this basically says you're 100% guaranteed that your prediction will have some kind of a label, because of the way that we've set the labels up. And then we've got the recall, which basically the tags that it should predict correctly. What did your model find, right? So based on what we have out there. And then finally, you basically get the model performance measure, and it gives you the precision and recall, at different thresholds, because we've got the ability up here to make our threshold bigger or smaller, depending on what the probability score that we want, when we're doing that precision and recall. So from there, we essentially can set up our prediction so that we deploy it to an API. We're not going to do that right now because that'll go somewhere. But then we get a URL. And when we talk about sort of all the work we're doing with the code behind, this is how we tap in to our API to be able to make a prediction based on something in, say, a web app that we've created inside our organization, right? And so this is how we tap into that model that we've created, where, you know, as I referenced earlier, the GUI tool is great for building your initial model and you know, playing around with it, playing with the testing, you know, doing some on the spot testing and things like that. But then when you actually go to operationalize it and we look back at our architecture, you're in fact using a lot more of a code base. You know, for instance, in our book, we use Python, where you're essentially you know, tapping into the API, you're sending it the image, you're getting back your results, and then you have the ability to then make a decision, you know, okay, was this prediction correct? Or it can just give you a result. Yeah, we're 99.9% sure that that's a Picasso, right? And that's all well and good. Sometimes that's all that people need. Or you can turn around and say, well, that's not correct, or give the user an option to say, yes, it's correct, or no, it's not correct, to be able to then go back and send the new image in to retrain your model. So the example that we use in the book, say, is we'll go through and we're using lobster tails. And we want to determine if a lobster tail has a problem, right? So if you guys think of what a lobster tail looks like, it's got the little flippers on it, right? It's got the ridges for, you know, the where all the wonderful meat is inside of it, and then, you know, there are certain distinguishing features about it. Even the color is somewhat distinguished, whether it be raw or cooked, as well as you know, could have some kind of disease on the shell or something like that. And so when we set up a system where we can analyze the tails as they're in process, doing sort of a final quality check before they get packed, you've got the ability to look at that tail as it's laid out and say, is it a good tail or a bad tail? Now, we wanted to do some reinforcement learning here. So what we did was we said, okay, you can now say, yes, this was a bad tail, right? So that's a positive action, even though it is a bad tail. Or no, it's a good tail, if you guys can follow me on that. And so you reinforce that model. We load that image, whether it be good or bad, to then go back and retrain that image every night, retrain that model every night, so that we're constantly improving the model. Hopefully you guys are able to stay with me there. I should have some kind of a graphic for that. I fully admit. So that was a little botched, but hopefully I was able to paint the picture for you there on that one. But if we go back to our slides real quick, you know, yeah, I'm missing a slide. Anyway, my time is up. You know, sorry I had to rush through some of that at the end there. It was just a little bit of front chatter in the front. But the portal here is customvision.ai. Like I said, you need an Azure account to go in and do it, and you'll have to spin up resources, whether they be free or standard tier. But you know, essentially, you can build this stuff very, very quickly. To do this lab, it took less than 3 hours, I want to say, from start to finish, and that includes, you know, all of the reading that goes along with it, and the deploying of the resources and all that kind of stuff. So, and it's you know, pennies to run a month just to play around with.
Very good. Hey, Chris, we do have some questions. I don't know if you can see the chat.
Sure.
But
Let me
you
pop
got
it up.
like a kind of a bundle here from
Yeah.
Chris.
Okay, let's see.
I see that I cannot use Azure machine learning or Databricks if I want to use object detection or segmentation libraries.
You can. Yeah. So that's not true, Chris. You can tap into the API from Databricks. So if you're using that model, you could do that. I can't remember off the top of my head, but there are some models, custom visions, I can't remember. You can containerize a good portion of them as well, so that you could use the models like on-prem using a container.
Very good. And then let's see, what about image segmentation? Is there a segmentation option in this no-code computer vision API?
Not that I'm aware of, no. In the GUI, and as I think about it, I'm not sure if there is even on the even in the API, you know, when you build your example, it with the code. I'm not sure about that. I don't believe so though. It doesn't ring a bell.
Got it. And then what models are used for object detection or classification in this computer vision API? Any specific ones like YOLO?
I don't know what the latest one is. It's a Microsoft proprietary one. You know, so basically, we've fed into the open source algorithms heavily, but then some of that we kind of go back and put our own little bit of a twist on it, if you will, to make it proprietary. It is highly documented, and a lot of this work's being done through MS Research, which they do open up, you know, for open source and those types of things. So you know, if you just do a quick search on Microsoft Research, you know, they have a lot of details in that in their site, you know, about a lot of the material that they use, if you will, to get started with this stuff. What do we got? Comment on the product per se, Amazon SageMaker. They all have their strengths and weaknesses. You know, Amazon SageMaker has been around a lot longer. It was deployed long before Custom Vision. But on the flip side, Microsoft received human parity for their Custom Vision. I want to say it was like back in 2016 for the model itself. And so a lot of times it comes down to, and this is true of Azure and AWS across the board, a lot of times it comes down to comfort level and specific features and aspects that you need, you know, because they certainly don't develop the applications in the same sequence, if you will. So there's a lot of capabilities that, or I wouldn't say even a lot, but there are some capabilities that one service might have that the other might not. And so I think it comes down to like a more specific, what are you looking for? What I've found in my experience is that folks who come from a Windows world tend to be able to use Azure a lot easier. They're more comfortable, it's more familiar to them. And then folks that kind of grew up in the Linux world or the open source world tend to gravitate toward AWS because it's just, for whatever reason, it's more comfortable for them. You know, and obviously AWS was out first and a lot of the tools were around earlier and all that kind of stuff too. So that all kind of comes into play.
All right, Chris. It doesn't look like there's any more questions. Guys, if there's any more questions, let Chris know.
Mm-hmm.
Oh, can you throw
yeah,
the slides?
I'll throw that on. Yeah, sure. Definitely, Guy.
Very nice.
I gotcha. Yeah. So like I said, looking for, oh, you know what? I'm not, you know what, Tim, I'll PDF these to you too, so you can share them on the site afterward.
Sure.
But yeah, so you know, basically shoot me a note, chris@bizdataviz.com. You know, a lot of irons in the fire. So if I don't respond right away, you understand why, but I will get back to you for sure. And I know that Pact is always looking for reviewers, technical reviewers and book reviewers, not just for my book. They'll reach out about other books, right? They'll send out a message saying, anybody want to review a chapter on cognitive vision, right? So you know, some great opportunities there to learn new tech as it's being sort of spit out, if you will.
All right. Everybody's giving you compliments, Chris. This has been
Awesome.
a very good session. Thank you very much.
Yeah, so I had to rush there, guys. I appreciate it. And, you know, reach out with any questions and whatnot. But, you know, buy the book when it comes out, too. I appreciate it.
You got it. Yeah. Well, Chris, I'm going to stop recording and let you go and enjoy your day. Everybody else, go and enjoy your weekend.